Hey robot makers, how you doing? Hope you're having a good day so far. So is the Pimoroni Servo 2040 the best board they've ever made? I certainly think so. I've added it to the PicoCat and I'll show you what we can do with that today. So let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole lot of fun along the way. Okay, let's get over to our keynote and have a look at what this is all about. Okay, yeah, so the session today is all about the Servo 2040. It's a yet-to-be-released board from Pimoroni. So let's have a look what it can do, what it is. Bit of a recap on PicoCat. We might have seen that video before, but it was quite a while ago that we looked at that last time. In fact, I think my cat was a kitten last time we put that together, and we've had another kitten since then, so it's at least one kitten old. How we put it together, how we upgrade it, the PicoCat, and we'll have a demo as well of some of the code, so I can't wait to show you all this stuff. So this Servo 2040 by Pimoroni, they sent me a prototype version. I'm allowed to share that with you, so I'm really excited. It'll be released, I understand, later this week, but that may change. It depends on lots of other things, but yeah, we think it's this week. So the Servo 2040 is a controller board for 3-pin hobby servos. It's got all the additional bells and whistles that make it ideal for robotics projects, which is exactly what I will love it for. When I saw that they were creating this, I was like, I have to have this. This is just one of the best boards. So some of the key features of this: 18 servos. You can add 18 servos to this board. So if you are used to using the PCA 9685 board, I think I have one around here somewhere. There we go. These can only do 16, and these are not really designed for actually controlling servos. These were actually designed for controlling LED lights. So you might be familiar with the PCA 9685 board. I've used it in quite a few projects before, so it looks like that. So yeah, 16. So this board already can top that. It can do 18 servos, enough for a hexapod walker. So if you want to build a hexapod walker, you can certainly do that with this board. It has 6 analog sensor headers, so your robot can sense its environment. You can see on the picture there, it has some LEDs as well above that. It's got 6 LEDs, RGB LEDs, to be able to show the sensor state or the current voltage levels as well. So we'll get to that in a bit. So current and voltage monitoring, that's something I've not seen before. That's something that these boards certainly couldn't do. So you can see how well your servos are performing, whether they're currently under strain. And you could pop up a message or make some kind of reaction in your robot, or even change its behaviour if it's pulling too much current. So we can actually stop our robot from sort of ripping itself apart using something like this. And one of the other really cool things is it has reverse polarity protection. Sounds like something off Star Trek, that, doesn't it? It just means if you pull the servo in the wrong way around, it won't mind about that. It will just help you protect your servos, because these things are not cheap. I've got a couple of servos here I was just showing you just during the countdown timer. So I've got one here which is a 20 kg digital servo. I've got that one I think from Hobby King, and there's another one here which is an even bigger one. This one is another, I think, from Hobby King, which is an absolutely gigantic beast. These are about £40 in the UK. So these things are not cheap. You don't want to be blowing these up. So something like the protection that these boards offer, that's something we're really interested in as well. Some of the other subtle features on this board you can see from that picture there. If you look at the header pins, they're ever so slightly off-center, and that means that when you're putting in like a header pin, it can hold it in place much easier than if they were all in a straight line, so you can solder it. It's just one of those really nice little attention to detail that you get from Pimoroni. There's also some other nice little features on there as well, such as this little crab fellow here. I love things like that. And you've got the usual boot button and reset as well that you would have on an RP2040 board. And that brings me on. So this board is powered by the Raspberry Pi RP20 module. So this chip, we've seen this before on the Raspberry Pi Pico, and it's on a bunch of other things. There is loads of these available at the moment as well. They're not one of the things that's in short supply. So you'll probably see lots of boards with this chip available. So it's got the dual ARM Cortex M0 running at 133 megahertz. It has its regular 264K of RAM, and this particular board, the Servo 2040, has 2 megs of onboard flash, so plenty of space for all our scripts and our programs to run. And it's got the usual kind of stuff that you would see on that Raspberry Pi Silicon as well. So we don't need to go over that. I think we've done that in a few other videos as well, but just wanted to call out that's what's powering it, and that's what gives it one of its unique powers. So the Raspberry Pi RP2040, as I said, is the same chip that's in the Pico. Previously, our Pico robot had to have a little Pico like this on a little board, and that would sit on its back. And then we had to have another board, such as the PCA 9685 board, plugged into that. So you require two boards to run. So we don't need to do that with the Servo 2040. We've just got one board with everything on board that we need. So single board, no need for separate microcontroller and server drivers. We've got an external power input as well, so we've got a nice big block we can put some external power into, so servos have plenty of power to make the robot move around. We have the software voltage and current monitoring. That's something I really can't wait to have a play with, so we can actually see what the current draw is on the servos and whether they're, you know, within an acceptable range or not. It's got the Quest connector as well for Quest components, so if we wanted to do something like, I don't know, an MPU like accelerometer, and we wanted to know if the robot was on its back or something like that, you could probably use the Quest connector to do things like that. And it's the perfect size for small robots. So when I saw this board, I was like, this is going in the PicoCat. There is just no question about it. It's the perfect size. It has a USB-C connector, so it's really nice and easy to get this connected up into your robots. It's the most modern type of connector. And like I said, it's being released very, very soon. So let's have a quick recap about PicoCat. So PicoCat is made up of a whole bunch of 3D printed parts and some standard servos. Now the very first version of PicoCat had, which is sat on my desk here actually, had the SG90 servos on it. So they're okay, they're plastic based servos, so they're not the best quality, but they are quite cheap and accessible. So let's have a look at some of the components that make up PicoCat. So we've got the head module. So I've got here's one I prepared earlier. There's the head module, and that's actually made up of lots of different bits that we'll look at in a second. We have the collar, the sort of shoulder area that attaches the servos into the sort of front of the robot. We've then got the tibia, which is the sort of the arms of the robot, and then we've got the feet. We've then got the main body, which is where we put the battery and all the electronics. And then we've kind of got a replica of the front of the robot, just kind of mirrored a little bit. So we've got another collar, another tibia, and another set of feet. And then at the back we've got the tail as well. So really, really fun, this particular project. So let's have a look at the head. It's got quite a lot going on this head module. So you can see that there's a head profile, which is, if we look at it side on, it kind of looks like a kitten or something. We have the eye mask, which is this sort of area around here. We've got the SR04 rangefinder, which we use in a lot of our projects for detected distance. We've got our little chin piece, which is at this rounded piece here. We have the nose, and we have the ear profile, which is this piece here. So we can have a look at how all this fits together. This was taken from Fusion 360. Yes, you can see all the different pieces sort of separated out there. And of course we've got a servo. Now that can be a SG90 servo, to be honest. It doesn't do a lot there, it's just making the head go up and down. But we can also swap that out because it doesn't actually require a particular depth or anything. We can use some of the newer servos that we'll have a look at shortly. So this is the head assembly. These are all the different pieces that make that up. In Fusion, this was just a slide from the previous video that we did on PicoCat, just as a reminder what this is all about. Here's all the servos. So this is what we've done to upgrade the PicoCat. We've taken all these servos that were SG90s and we've upgraded them to a slightly newer version of the a slightly better quality version of that servo. So it's called the DS929MG. MG is like Metal Gear. The SG90s. They're okay. They're just a cheap entry level one, and they work fine for PicoCat. To be honest, I just prefer these much better quality servos. So you can see there we've got the one on the head, which just makes the head go up and down. We have one on the neck that makes the head go side to side. We've got the front legs, the front foot, and that's left and right, and then we have the back legs and the back feet, and then finally the tail. So in total that's 11 servos, so it's quite a lot. This is why I wanted to showcase this on the Servo 2040, because it does actually use quite a lot of the servo boards there. So let's have a look at some of the upgrades that I've had to make to PicoCat to accommodate this board. So the first one is the body. So the body had to be widened only slightly to be able to take the new Servo 2040. I mean, we're talking about a millimetre or so. It was only a small adjustment, but I did add some mounting holes as well for some standoffs. I'm a really big fan of standoffs. What I mean by that, if I just grab one here and show you on the screen. So these are these little black, let's see if I can get that on screen a bit easier. These little things here, sometimes they come with a piece already on there that you can then screw another one into, and sometimes it's just the singular screw like that. It's like a little hexagonal barrel shape like that. So I've used a couple of those just to lift the board up, and it means we've got somewhere to put the battery underneath as well. So yeah, works perfectly with the original design of the body chassis. Next up was the collar. So I've just had to make these slightly deeper. So the DS929MG servos are ever so slightly more deeper than the SG90 ones, and it did mean I had to sort of go and change every other aspect of the robot. So that's why I'm currently printing out, if I just show you here on my 3D printer, it's currently printing out some of the legs there for the second one, this yellow version here. There's the first one. I have got an entirely unbuilt orange version of the robot as well, but that one it didn't really do it for me. It was the design of it wasn't quite as strong as this original design, so I've gone back to that original design. So yeah, I've added the mounting holes. I think that's the same text as the previous slide actually. So then the tibia, this is again widened. We had to make that slightly wider for the new DS929MG servos. Pretty much the same as the previous model. It is slightly simplified, so I've made it just quicker to print, to be honest. And then the foot again had to be adjusted because of the servos. They had to make it a bit deeper, and again I've just made that ever so slightly simpler and quicker to print. And then finally the tail. There wasn't really much I needed to do on the tail. I did simplify it. I got rid of that hole that's in the end. There's like an extra piece where you could put like a weight on the end, and I think the idea is as the robot walks and moves side to side, you can swing the tail round and kind of counteract a little bit, but it's really not that heavy to do that, so I've just got rid of that. Okay, and these DS929MG servos, so I modelled one up here in Fusion 360. So they're full metal gear, meaning that they are really, really powerful, really strong. You're not going to get that sort of nylon mesh, grinding of the gears that you'd get on the SG90s if they slip. These are not going to slip, these are going to be really strong. There is a full adapter set for dampening the mount points. So there's like the little rubber things that go into the sides of the servo, and then there's like these little copper inserts, and then you can screw them in, and the idea is it squishes it between the servo and the thing you're mounting it to, and gives it sort of a rigidity but with a little bit of cushioning as well. So really, really good quality, and I really do like these servos. A little bit more expensive, but you do get what you pay for. They're really high resolution as well, so one of the reasons I did stop working on the PicoCat originally is because that PCA 9685 board I found wasn't very accurate. Sometimes the servos would overshoot, or they wouldn't go to the correct position that you wanted to. And what I found is with the Servo 2040 and with these new DS929MG servos, everything is just spot on. Really, really good. So very accurate positioning, fast response, constant torque throughout the travel. So it's very, very powerful. I had this on my desk power supply, and it's very, very strong. Okay, so if you like what I do, make sure you give this channel a thumbs up. Give me a comment. Tell me if you are going to build your own PicoCat, whether you've searched out OpenCat or Nibble, which is what that thing has now gone on to by its creator, the guy who runs Pet.io, I think it is. And also subscribe if you want to make sure you get more videos like this as well. Make sure you hit that little bell and notification thing, and you'll get notified next time I go live with stuff. So let's have a quick look at some of the MicroPython code. We'll actually run some of the code in Thonny as well in a moment or two, but I just wanted to give you a quick flavour of this as well. So creating a servo couldn't be easier. So the first thing we need to do, we do need to flash the board with the Pimoroni's version of MicroPython. Some people don't like that. I really do, because it makes it really easy. All batteries are included, everything just works. And as they brought out more and more stuff, they've added those as additional libraries that are in that package as well. So it doesn't take any extra space up really, and everything just works. So we import servo from the servo library with a capital S, and we can also import servo 2040 to get some constants as well in there, such as the servo names, and they're all numbered 1 to 60 to 8, yes, to 18, which just makes it a lot easier. So once we've done that, we can then create an object that uses one of those. So I've just gone for head equals servo, and then in brackets servo2040.servo_1 in all caps, and that means it's going to use the first slot on the Servo 2040 board. We can then enable it. You can enable and disable the servos, which is pretty cool. So once we use it, it automatically enables, but we've called it out specifically here. And then there's a couple of functions we can do right off the bat. So if we go head.to_min, it'll go to the minimum value for that particular servo. So if you think a servo's typically got a range between 0, like 90 and 180 degrees, minimum will be 0 and maximum will be 180. So we can either use values, we can use angles, we can use percentage. It's all built into the library, the really cool library that Chris, who's in the chat today actually, has created. So yeah, head to min will make it go to the minimum position. We can then print out what that value is. If we do head.min value, it'll tell us what that value is. We can then make it sleep for a second. We can then do head.to_max, and it'll go to the maximum position. We can then wait a second, print out that max value, and then we can make it go to the mid value, so in between those two. So mid value will take us to that, and you can do mid_value to grab that value back, or you can do to_mid to send it to that position, and then we can disable it at the end. So we'll run that code in a minute, and I'll show you what that looks like. It's really fun. That was the first piece of code I got working, and then I just had to figure out which particular limb was connected to which servo number. So I've just assigned all the different limbs to all the different servo numbers. So just a reminder, I do go live every single Sunday at 7 o'clock GMT or British summertime, depending on which time of the year we're in. So we're currently in British summertime. The clocks went forward this morning, so we all got 1 hour less of sleep. If you want to join us on Discord as well, you can go over to our Discord server. So to get access to that, just go over to action.smarsfan.com/join-discord, and you can get a sign up there, completely free, and helps you carry the conversation on about this. So let's have a bit of a demo, shall we? Okay, so I'm going to go over to, just going to go back to me for a second while I bring up Thonny, and let me just move that out of the way. Just arrange my windows here so we can see what's going on. Right, so if I go over here, so this is the code that I've got working. So this is the head test. This is the one that we've just seen on the screen. So we're going to create a head object, we're going to enable it, we're going to print out some values, and we're going to set it to the minimum, maximum, and mid value. And what I want to do as well, let me see the best way of doing this. If I go to the overhead shot, so this green robot here, this is the one that we're going to be controlling. I've actually got the Servo 2040 board plugged into the new one, but I've not got all the correct servos yet for that, so it's kind of just using it as a surrogate at the moment. So we've got the code down here. I'm just going to move my windows about so you can see what's going on. So let me just bring this down, and let me just adjust that height a little bit as well. I can do that, and then we can see what's going on. Okay, there we go. Okay, so what I'm going to do, I'm going to run this code, so I can see there that the MicroPython device is attached. I've got the correct version of the Pimoroni MicroPython installed, the absolutely up-to-date latest version that Chris literally knocked out about an hour ago. So that's up and running on there. Thank you for that, Chris. I really do appreciate that. Okay, so I'm going to click run now. Watch the head. The head's going to go to its minimum value, its maximum value, and then the mid value. So let's just run that again. So minimum, maximum, and then mid. And if you look at the printout there, it says minimum is -90, maximum is 90, and the mid is 0. So rather than saying 0 to 180, the midpoint is considered to be 0, and we can either go -90 or +90. So I do like the way that works. That works for me. So there we go, nice and simple. Okay, so that is the head test. I'm going to go for a bit more of a complicated test now. Let me show you some of this code in a bit more detail. Let's open this up, and we can show you a bit more of this code. Okay, so what I'm going to do, I'm going to import quite a few things on here. I don't think I need the pin and the I2C anymore. We don't actually use that, and we don't use the, in fact, that's the old code, isn't it? Yes, that's why I was going to say. We don't use any of that stuff. It's a lot simpler now. So the first thing I'm going to do is I'm going to define a class called limb, and limb is going to emulate later on when I build this out a limb, so it'll be an arm as well as a foot. So we can just say create 4 of these in an array, and then we can get it to do various things. One of the other functions that I created just to help me configure and figure out which servo pin was connected to which servo, was to create a wiggle function. So wiggle this servo, and I simply just say for 3 times, make it go plus and minus 20, and it just kind of wiggles the limb a little bit. The reason I did plus and minus 20 is because if I set it to the max value, if that particular servo is connected to something that has a limited range of movement, it might break the model, so we don't want it to do that. So that little wiggle function there is just a way to help figure out where we are. Okay, so then the next thing I do is I've created a class called PicoCat. First of all, I give it no name, and we've got a legs array. Again, I don't think I use that at the moment. And then what I then do is set up each of the servos, servo 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think 5's missing out of there just because I hadn't plugged it into 5. There's nothing wrong with 5, I just missed that when I was doing it. So what I've then done is I've given each one of them a more user-friendly name. So head is obviously the head of the robot, neck is the bit that makes it turn left and right, and then we've got front right foot, front left foot, front left leg, front right leg, the tail, the back right leg, the back right foot, the back left leg, and the back left foot. So quite a lot of things going on there. The first thing we do when we initialize that class is we say PicoCat is online, and I've got a property here. If you've not used Python before, these might look really like what is going on, but it's essentially you can create a value that you can set and check without actually calling it as a function. You can just do .name and then you can pass it a value, or .name and grab that value. So it makes it really, really easy to use. So I've created some really fun little behaviors now. So nod makes the neck go from 0 to minus 50 to 0, so it'll nod like that. We can get it to wag the tail a number of times, and it'll make the tail go from 50 to minus 50 as many times as we pass in times. We've got look left, we've got look right, we've got look ahead, which is just those mid values, min and max values. Stand up. So stand up is basically just setting all the legs, all the feet to a specific position. So this took a little bit of working out just to begin with, but essentially I've set it to 50 and the foot value to 0, and that seems to make it work because the angles on each of these servos, they're not stood up 90 degrees, they're actually a funny angle, probably around 45 to 50 degrees, and therefore that's why we had to set it like so. And some of the values had to be negated because they're on the mirrored side of the robot, so what would be 50 degrees on one is like minus 50 degrees on the other one for them both to work in the same way because the servos are sort of back to front. So that's to make the robot stand up. And then I thought, I'm sure we could do better than that, because what this will do is it will just instantly set the robot to the stood up position. And what I wanted to do was make it gracefully stand up and gracefully sit down. And we can do that by checking to see if the value has reached the target value. And that's what all this horrible code here does. It checks to see, is the current value less than or greater than that current value that we're trying to get to, and it just takes or adds 1 to that value. So each time it goes through that loop, it will make it gradually get to that position, and then once they're all at the right position, all of those statements there will be true. I'm sure there's probably a better way of coding that, but that's was just me testing this out. And then sit is similar, so between 50 and 90, which is just the angles we're going for, we can just make those sit down, and it sits like a sphinx. It's really quite satisfying. Okay, and then here we go. This is the main block of the code. So we're going to set the name to PicoCat. Sorry, we're going to create an object called cat. We're going to set the cat's name to pixel. We're then going to make it nod. We're going to make it look left, look right, look ahead. We're going to make it stand up, wag its tail 10 times, and then sit down. So we're going to make it do all those things. And then I'm going to show you on the overhead camera. In fact, I'm going to show you on this camera because it's a bit easier to see that. So I'm going to run the code. I'll run the code using this view first of all, just so you can see what's going on. And then we'll run it again a couple of other times. So let's just bring this down here. And I love that it just works. It just works. And this is all down to this Servo 2040 from Pimoroni. Right, so let's run this code. It's going to be really quick. So I'll run it a few times. So we run that, it's nodding, it's looking left and right, he's stood up, he's wagging his tail, and then he's going to sit down. Let's run that again. Wagging his tail, and then it sits down. And you can see that he's sort of sitting down and all these limbs are coming up. Probably need to work on that a little bit better. So let's try seeing that from a different camera angle. I'm just going to grab hold of it first of all, just so that it doesn't fall over. So he's going to look down, look left, right, stand up, wag his tail, and then he's going to sit down. You can see there each of the limbs are sort of going up. Let's try this from the other way around so that we can see the tail wagging. So if we do looking left to right, standing up, wagging its tail. It's more of a dog, isn't it, than cats don't really wag the tails, do they? And there we go, there's it sitting down. So this is, you can see all there, the blue SG90 servos, and then the newer version of the PicoCat. You can see we've got the Servo 2040 there, we've got a nice new tail on there, and we've got these lovely black DS929 servos as well. So let's just go to the overhead, and you can probably see that sort of side by side, so pretty much the same size. The tail's a little bit shorter. You've got no head at the moment. I'm going to print out a new head just so it's all the same colour, and I've got an entire unused cat in this box here. So this was a slightly different design. Let me open this up and show you this one. So this one was a slightly newer version. I'll show you some of the pieces from this, and I'll tell you the reasons why I didn't use this. So the idea with this, let's just grab that on there. So you can see there, that's the collar, and the collar is made up of 2 pieces and 2 ovals, and sandwiched between that is the servos, and then you just screw the servos in there. But look how solid that is without actually having any screws in there. It's quite robust. It's quite a good design, that. However, the thing that lets it down is you really, the only thing that's keeping these legs in any kind of alignment is the spindle itself, and on this one they're plastic, so it wiggles a little bit. You've got 2 kind of degrees of freedom there, but as you can see, it's not particularly very strong, and it's likely to just fall over and not respond very well. But yeah, it might be okay. I might try this one out. I'll get another couple of Servo 2040 boards and try it on this as well, because it will work quite well. The body was a slightly different design on this one as well. It kind of slotted into those pieces there at an angle, in theory. I don't think I got this satisfactorily working. But this wasn't my design, this was somebody else's design. But that's what the orange head belongs to on that one. So there's a little neck piece there as well. I think the purpose, the intention behind that particular model is that you don't need any screws, really. You can just fit everything together and it'll all click into place. I'm a big fan of screws. I think they do actually give the model a lot more rigidity. So let's go back to the code. Let me see, there we go. Now, because this board is so new, there's quite a few things I haven't tried on here yet. So I haven't tried looking at the servo current load and checking to see what that is. I am aware that that does actually work. I think if I go back to me for a second while I just load up the code. So on the Pimoroni GitHub, they have got some examples there. So current metering, for example, this is how we would do it. So if I go to here, we can see we're setting up the analog inputs. We can grab what the current value is of the current servo that's been selected. We can read in that value, check against the reference voltage that we're looking at. Do that a couple of times just so that we get a good reading of that, and then we can print that out and round it up. So we can say as a percentage as well, the percentage is current divided by the max current, and so on. So yeah, you can see that there's quite a lot of example code for this particular robot. I just haven't run, for this particular board, sorry, I haven't run a lot of these yet, but we've got things like calibration. We can make nice rainbow effects on those LEDs because they're RGB LEDs, so we've got the whole, millions of colours that we can run through there. We can tweak all the different servos, have multiples of those running at the same time. We can read the values. That's a cool thing. That's something that I liked about the Lego Lego servos, if you've ever done any programming in the Mindstorms Lego stuff, you can actually read what the current servo value is. So you can read what it actually is rather than what you might have set it to and then forgotten about. So that's pretty cool that you can actually read that. What else we got? We have sensor feedback, so we can do things like the distance sensing. We could use like a laser sensor, an MPU to figure out what orientation we are, all that kind of good stuff. Now, one of the really cool things, and I haven't dug into this yet, is server clusters. So we can grab a whole bunch of servos and treat them as like one block of servos, but control many aspects of them at the same time. And this uses the RP2040's PIO system. So this programmable I/O. This is really, really cutting edge stuff. I've not played with this yet. It's really, really new, but it means we can do some really edge stuff and free up the main processor to do other stuff as well. So really, really impressed that Pimoroni are taking this thing to the next level. So yeah, really, this is, for me, is just the best board they've ever made. So the only things I was thinking about, if I was to sort of critique this, where I think it could do with some extra stuff. So we have on the back here the power inputs. So we could put in an inputs there to power the servos, so that they're not just taking power from the data in and power in from the wire there, because if we're running this on a battery, you'll essentially need to split this into two parts. You need one to power the servos and one to power the board logic. And ideally, I'd just like to be able to plug in, using a little GST connector, a LiPo battery. Just looking around to see if I had a LiPo battery to hand, but I don't think I've got one actually. But you know what I mean. We essentially want to have something where we have one battery pack in the robot, and then there's a power management thing that will send some power off to the servos and some off to the logic. Now, it might just be that I don't understand and I've not read enough of the documentation yet, and it does actually do that, but I couldn't see how we could easily do that. It looks like you have to have two sets of power going in there, and therefore two batteries, and space is limited on this robot. We could sling a battery underneath and have a battery underneath the board. If I grab hold of this and show you here, so the yellow one is the one with the Servo 2040 board there, so you can see it there, and I've got it on some standoffs, so there's actually quite a bit of space underneath there where we could have a nice battery sat there, and you can see some of the other things on there as well. The RGB, oops, down here, oops, sorry, I'm just making a mess of this, and all those edge connectors as well. And look at all those servos we've got in there. I've got 11 servos plugged in. I've not even touched the RGB LEDs yet. That's something else I'm going to be adding to it once the limbs are finished printing out. They're still printing. I think they've got another couple of hours to go on there as well. So this is part of the video where I'm saying, if you're watching this on replay, this is the part of the video where I'll say thank you for watching, and I shall see you on the next one.